I'm Terry Klinker. We're going to continue with our graphical solution of our Flair Furniture process. If you remember correctly, we were trying to maximize profit. Our decision variables were we knew we could decide how many tables we could make and how many chairs we could make. We made $7 for every table, $5 for every chair, so we wanted to maximize this. For carpentry, took 3 hours to make a table, 4 hours to make a chair, and we had 2,400 available. Paint, 2 hours to paint a table, 1 hour to paint a chair, and we had 1,000 available, and we had non-negativity. We went through and graphed. We found out we were going to graph it at the extent. We were going to make sure we used all of our constraint, and that's what we graphed. Everywhere on this line, we found 2 points on the line, plotted it. Everywhere on this line, we're using 2,400 hours. We found 2 points on this line, we plotted it. Everywhere on this line, we've used 1,000 hours of paint. We went through and said, okay, we needed to be on this side of the carpentry line, this side of the paint line. We needed to be in quadrant 1 to meet non-negativity. And we identified the region we need to operate in. Whatever combination of tables and chairs we produce to maximize profit, it must be in this red area. The red area shows us all values of tables and chairs that are feasible. It is referred to as the feasible region. Also, we have what's called the corner point theorem. The corner point theorem states that wherever we have a corner point where 2 constraints are maxed out at the same place, our optimal solution, the best we can do, the most profit we can make, must be at one of these corner points. Now, why does this make sense? Let's go back and think about resources. The more resources you have, the more money you can make. The more resources I have, the more tables and chairs I can make. Therefore, the more of my resources I use, the more money I should be able to make. If I give you more resources, you'll be able to make me more money. If I use more of my resources, I'll be able to make more money. Where I have a corner point where 2 of my resources are maxed out, I have maxed out 2 resources. I've used the most of 2 different resources. In between these points, between this point and this point, I've only maxed out carpentry. So at a corner point, you've used more of multiple resources. So that's where your optimal solution will be. So what we want to do is find out what's the profit at each of our corner points, and then we'll pick the corner point that gives us the greatest profit. So we'll develop a table. Our table will have 2 things on it. The first part will be the corner points. All right, I have a corner point here at the origin. It's where my axes cross, and you need to include it. So I've got a corner point at making no tables and no chairs. I have a corner point here at 500 tables and no chairs. Note that this is not a corner point. This is a point on this line, but it's not in the feasible region. I can't use this as a corner point because it's infeasible. I can build 800 tables. I have enough carpentry to build 800 tables, but I can't paint those 800 tables. It takes me 2 hours to paint a table. If I had 800 of them, it would take 1,600 hours. I only have 1,000 available. So don't take a point that is outside of the feasible region. I have no tables, 600 chairs is a corner point. And then I have this corner point here in the middle of the graph. I don't have numbers for that yet. However, if you take a look at it, it shows me that the values of x1 and x2 at this one point satisfy both of these equations. It's the only point on the graph where x1 and x2 satisfy both of these equations, where I equal, not less than or equal to, but actually equal the use of all of these constraints. So what I need to do, I've got 2 equations. I have two variables. I just need to simultaneously solve for them. So we come over here and we say, all right, 3x1 plus 4x2 equals 2400. 2x1 plus x2 equals 1000. There are different ways to do this. You can pick your favorite way, depending on how good you are at algebra. My favorite is to just simultaneously solve them by doing this. I'll multiply this side by minus 4. All right? So 3x1 minus 8x1 gives me a minus 5x1. 4x2 minus 4x2 is 0. 2400 minus 4000 is a minus 1600. x1 then will be minus 1600 over minus 5, which is 320. These two cross at 320 tables. I can then take this number for x1, plug it back into one of the original equations. So 2 times 320, that's my value for x1, plus x2 equals 1000. x2 equals 1000 minus 640, which equals 360. So my value at this point is 320 tables, 360 chairs. So my corner point here is 320, 360. Now there are different ways to do this, all right? You've seen me go through it. I'm going to erase that lower one. Another way to do it, which people might find simpler, is solve for one of them and then go back and plug it in. So in this case, I could say, okay, x2 equals 1000 minus 2x1. Now I can plug this value into this equation. 3x1 plus 4 times x2 equals 1000 minus 2x1 equals 2400. Now I can go through and solve for x1 and do the exact same thing I just did. Which way is better? Neither. Whichever way works for you is better. All right? So do it whichever way you want. Once I've solved for x1 and x2, the next thing I do, I've got all my corner points, and I turn around and I put them, I find out what the objective function value is at each corner point. My objective function, again, is 7x1 plus 5x2. So I'm simply going to plug in x1 and x2 into that objective function and find out what my profit is. In this case, I've got 0 and 0. 7 times 0 plus 5 times 0. Do you have your calculators out? I think that comes up pretty close to 0. If I don't make anything, I make no profit. 500 times 7 plus 5 times 0 gives me $3,500 of profit. 7 times no chairs plus 5 times 600 chairs gives me $3,000 of profit. 7 times 320 plus 5 times 360. 7 times 320 is going to be 2240 plus 30, 1800. That's going to be $4,040. Take a look at what's the most profit. 4,040 is the most profit. 320, 360 is the solution. I will make my most profit if I design my facility, my resources, to produce 320 tables and 360 chairs.